Hello. This visual abstract consists of our paper size effect in concrete beams, that is using a numerical investigation. This paper is based on the size effect law. Objectives of the present study. This research proposes the finite element modeling, that is a multi-scale modeling used to examine the size effect on the fracture characteristics of notched concrete beams using the 3-point bending. Beams are adapted in the present study 75 mm to 1000 mm using the CAE software. In this paper, method adapted using two types of aggregates randomly distributed, that is spherical aggregates as well as realistically shaped aggregates. These two aggregates are distributed in the concrete by using the Python script, and then entire model is simulated using the Abacus CAE software. Geometrical properties of beams adapted shown in this table. Here, span to depth ratio considered is 3 and notch depth ratio considered as 0.25. This sketch shows the numerical model adapted. First figure illustrates the spherical shape aggregates, and second figure illustrates the realistic shape of aggregates used in this study. And then interfaces are created by using the cohesive zone model, in which cement matrix and then interfacial transition zone are created around the aggregates as well as inside the aggregates. After analysis, load deflection curve for all the beams considered plotted, and then fracture energy is calculated using work force method. Then what we have observed, fracture energy keeps on increasing as the size of the beam increases, and then suddenly it's become in flat what we can consider here 500 mm to 1000 mm depth of beams. Graphs are plotted using the size effect law. Parameters are calculated, which is explained in the paper, and then we have compared our numerical study with the experimental as well as the strength criteria, which will be size effect law. What we can observe, it is exactly our numerical modeling system comparable with the experimental as well as size effect law. Important conclusions of present study is our numerical model as well as experimental method both are correlated with the Bažant sign effect law, and also it is matches with the size effect parameters. Then both numerical and experimental results indicates decreasing trend in nominal strength as the beam depth increases from 75 to 1000 mm. That which aligns the Bažant size effect law for predicting the size dependent flexural strength of the concrete beams.